Okay, let's do matrix inverses. Okay, until now we've learned how to add matrices, subtract matrices, multiply matrix by a scalar, transpose a matrix, and multiply matrices among themselves. Okay, and of course we went over all the algebraic properties of all these operations. Okay, so today in this lesson, I will show you how to find the inverse of a matrix. Okay, so let me write this down. The inverse of a matrix. Okay, you will see that it does not always exist. Okay, let me first define what the inverse of a matrix is. So if A is a square matrix, a matrix B is called an inverse of A if when you multiply A by B, you get the identity. And same if you multiply B by A. Okay, so in other words, the inverse of A is the matrix by which I must multiply A to get to the identity. Okay, so just a reminder of what the identity is, in case you forgot. Okay, so the identity matrix is, of course, it's the matrix that has, well, depending on the size, it is the matrix that has ones in the diagonal, in the main diagonal, and zeros everywhere else. So here, for example, I drew a 3 by 3 identity, but there could be different sizes depending on what size A and B are. Okay, so this is what the inverse of a matrix is. Okay, if such B exists, okay, in other words, a B for which A times B is identity, then A is said to be invertible. Okay, we call it an invertible matrix. Okay, and we write B is equal to A inverse. We write A with a little -1 on top. That's what it means. That means A inverse. Okay. Let me give you an example. Show that. So matrix, let's say B is equal to, so I had an example written down. 1, 2, 3, 7 is an inverse of A, which is 7, -2, -3, 1. Okay, so show, that's the question. Show that A and so B is the inverse of, is an inverse of A. So how will we do this? Okay. Well, very simple. We would just multiply them and see if we get the identity indeed. Okay. So solution. Let's do A times B. So it's a good little review on matrix multiplication as well. So A times B is 7, -2, -3, 1 times that A and B is 1, 2, 3, 7. So let's multiply. So 7 times 1 plus -2 times 3 is 7 minus 6 is 1. And then 14 minus 14 is 0. And then -3 plus 3 is 0. And -6 plus 7 is 1. Good. And then let's do B times A. So B times A is 1, 2, 3, 7. That's B times A, which is 7, -2, -3, 1. And what do I get? 7 minus 6 is 1. 0. 21 minus 21 is 0. And -6 plus 7 is 1. Perfect. Perfect. Okay, so we verified that A and B are inverses of each other. Okay, in other words, B in this case is equal to A inverse. Okay, if you have questions, if it's not clear, okay, you could pause the video and look at it again. Okay, so that was an example where I give you two matrices. One is the inverse of the other, and I ask you to verify that they are one inverse of the other indeed. Okay. What if I give you a matrix and I'm asking you to find the inverse now, or an inverse? Okay. So here's an example. Let's try it. Find the inverse of, okay, if it exists, A equals, so let me give you a matrix here. Let's say 2, 1, 5, and 3. Okay, so let's find the inverse of A. How can we proceed here? So the matrix that would be the inverse of A is the matrix by which I must multiply A to get to the identity. Okay, so let's call this matrix B. So let B, and I'm gonna put all the entries as variables. So let's say A, B, C, D. B, the inverse that we are looking for. Okay, so the inverse of A. So we must have, for sure, we must have A times B equals to the identity. Okay, so that's what it takes for B to be the inverse of A. This means that A 2, 1, 5, 3 times B, which is A, B, C, D, equals to I, which is 1, 0, 0, 1. Okay, so far so good. And let's do the multiplication in the left, on the left, okay? I'll separate this in two. So what do we have? If I multiply this matrix by this one, what do I get? So let's see, 2A plus C. That's my first entry here, 2A plus C. Then my second entry will be 2B plus B. Then 5A plus 3C. And then 5B plus 3B. This is the product on the left. And on the right, of course, I still have my identity matrix, 1, 0, 0, 1. And these two matrices need to be equal. In other words, I need to have 2A plus C equals 1, 3B plus D equals 0, and so on and so on. Okay, so let me write this system here. So I have 2A plus C must equal 1, and 5a plus 3c must equal 0. And on the other hand, I must have 2b plus d equals 0 and 5b plus 3d equals 1. So I have here a little system with 2 equations, 2 unknowns. That's very easy. And here as well, 2 equations, 2 unknowns. I could solve this pretty easily. Okay, so let's do this. There's many ways to do. I will go by doing equation 2 minus 3 times equation 1. Okay, so 5a minus 6a, I get negative a. 3c minus 3c is out. And then 0 minus 3, I get negative 3. And so I get a is 3. And if I plug in a equals to 3 here, I will get c equals negative 5. Okay, so I'm not wasting too much time on this system because this is high school stuff, and I'm sure you could get this. Okay, it's a very simple system to do, just to solve. And here, same idea. I will do equation 2 minus 3 times equation 1. I will get negative b plus 0d equals 3. No, equals, sorry, 1. This plus 3 times, this minus 3 times that. So I get still 1. And so b is equal to negative 1. And d, if b is negative 1, then d is 2. And here I get my matrix A, B, C, D. Very simple. So matrix B is equal to, so A, B, C, D. And there you go. This should be the inverse of A. Okay. How do I verify that I have the correct answer? So of course, I will just multiply B by A and see if I get the identity. So let's try. So B times A or A times B, doesn't matter. 3, negative 1, negative 5, 2 times A, which is 2153. What do we get? So 6 minus 5 is 1, 3 minus 3 is 0, negative 10 plus 10 is 0, and negative 5 plus 6 is 1. And so there we go. I just found the inverse of this matrix. Let's now try to find the inverse of any 2 by 2 matrix. Okay, in general. Let's try to find a general formula for this. Okay, so example, let A equals to the matrix in general A, B, C, D. Find the inverse of A. So A inverse. Okay, this is a question. Okay, so let's A inverse equals to, so I'm looking for this matrix, W, X, Y, Z. Okay, so again, we must have A times A inverse equals to I. Okay, so A times A inverse equals to I, which means that A being A, B, C, D. So these are given, and W, X, Y, Z is what I'm looking for in terms of ABC. Okay, basically that's what I'm looking for. 1, 0, 0, 1. Okay, so let's proceed exactly like we did before, except we don't have numbers anymore. So before we had 2, 1, 3, 5, I think, I remember, something like that. 2, 1, 2, 1, I don't know, I don't remember, okay? And this time I have A, B, C, D. So let's try. I multiply the left, so I have AW plus BY. Then I have AX plus BZ. Then CW plus DY. And then CX plus DZ. This is the left product, and it has to be equal to the identity matrix. Okay, so this means that AW plus BY equals 1. CW plus DY equals 0. And on the other side, AX plus BZ is equal to 0. And CX plus DZ is equal to 1. Okay, so let's try. Let's see what we can do here. So from here, I see that CW is equal to negative DY. And so Y is equal to C negative CW over D. Okay, if I isolate Y here, that's what I get. Let's replace it into the top equation. So AW plus B times Y, which is this, negative CW over D, must equal to 1. Okay, let's multiply everything by D. So ADW minus CBW equals to D. And therefore, I could find, if I factor out a W, I get W times AD minus BC equals to D. And so W is D over AD minus BC. So here's an expression for W. Now let's use the expression for W to find the expression for Y. Okay, so I will replace the W here by D over AD minus BC. So C times D over AD minus BC plus DY is equal to 0. So this means that CD over AD minus BC is equal to negative DY. If you divide both sides by negative D, you will get that Y is negative C over AD minus BC. Okay, so I have two results already in my matrix. I just found what the W is, and I found what the Y is. I need to find what the X and the Z are now. Okay, I'm just going to erase this side. Let's now take these two equations, and I'm going to proceed the same way. So I will do AX equals negative BZ. Which means that Z is negative AX over B, which I'm going to replace in the second equation. and I get cx plus d times z, which is negative ax over b, and that is equal to 1. Okay, let's multiply everything, both sides by b. So I get bcx minus adx is equal to b, which means that x times bc minus ad is equal to b, and so x is b over bc minus ad, but I want the same as here, ad minus bc, so I will flip this and change the sign. I will get negative b over ad minus bc. I just found x. Okay, to find z, I will just replace the x up here by this value. So a times x, which is negative b over ad minus bc, plus bz is equal to 0. And I can now isolate the z. Okay, so negative ab over ad minus bc equals negative bz. Divide everything by b, by negative b. I find z is equal to a over ad minus bc, and I just found z. Okay, so let's go back to the beginning. We had A inverse equals to WX, Y, Z. So that's going to be equal to, so W, X, Y, Z. Well, they're all divided by AD minus BC. So I could pull out a 1 over AD minus BC. And what's left inside? So X is negative B. Oh, no, sorry, that's W. It's not X here. So W is here, which is D. X is going to be now negative B. Y, WXY is negative C. And Z, which is just A. And this is how I find the inverse of A. Okay, so let me just write this result here. A very important result. So if A is the matrix A, B, C, D, then A inverse is equal to, so 1 over AD minus BC times D negative B negative C A. Okay, very big result here. We just proved it. So this here is how you find the inverse of any 2 by 2 matrix. Okay, the only problem is that if AD minus BC is 0, then we have a problem because we cannot divide by 0. And so that would mean that the matrix is not invertible. Okay, so if AD minus BC is 0, you will never be able to find an inverse. Okay, so this here AD minus BC, this is called, and it's not that important for now because there's a whole chapter on this. This is called the determinant. Of A. Okay, and this matrix here is called the adjoint of A. All this we're going to see again in the next chapter. Okay, so what's important here to note, and this is important in this chapter, if, so note, important note, if AD minus BC is equal to 0, then matrix A is, so we call this non-invertible. Okay, or we also call it singular. It's called the singular matrix. Okay, so not invertible or singular means the same thing. Means that the determinant does not exist. That means, sorry, that means that the matrix, the inverse doesn't exist because the determinant, this is called the determinant, is 0. Okay, AD minus BC is nothing other than the big diagonal minus the small diagonal. Okay, the main diagonal minus the other diagonal, AD minus BC. If that gives you 0, matrix is not inverted. Let me just write down the formula we just figured out. So if A is A, B, C, D, then A inverse is 1 over AD minus BC times D minus B minus C A. Okay, so this we just figured out. Let's use this formula to find the inverse of a matrix right away. For example, find A inverse if, so first of all, let's say A is the matrix 3, 2, 2, 5. Okay, and 2, let's say A is the matrix 1, 5, 6, 30. Okay, that's fine for both of them. I can do it right away here. So A inverse, in this case, will be, so 1 over, so AD, so 3 times 5 minus BC, which is 2 times 2, times the matrix. So D, which is 5, negative B is minus 2, negative C minus 2, and A, which is 3. There you go. So we have 15 minus 4 is 11. So it's 1 over 11 times 5, negative 2, negative 2, 3. Okay, so you could verify if you multiply. Okay, if you multiply A by A inverse, you should get the identity. Let's try this one. A inverse equals 1 over, so 1 times 30 minus 5 times 6 times, and this will be D, negative B, negative C, and A. And 30 minus 30, we get 0. So 1 over 0 times this. So of course, this does not work. So in this case, A is not invertible. So matrix A here is not invertible. Okay, it's a singular matrix. Because as you see, AD minus BC is 0. Okay, AD minus BC is equal to 0. So this is why A is not invertible. Okay, So all the questions that you have on this, I will answer in class, of course. Now the question that you might have now for sure, pretty sure, is that very good. We got the inverse of a 2 by 2 matrix thanks to this formula. Okay, and we also can recognize if it's not invertible thanks to AD minus BC, like here. But what happens if we have a 3 by 3 or a 4 by 4 or and so on? Okay, so we could do like we did before. We could do the matrix times A, B, C, D and try to find A, B, C, D, so that it gives you the identity like we did for a 2 by 2. If it was a 3 by 3, we would have A, B, C, D, E, F, G, H, I. So it would be 9 variables and 9 equations. So it gets a bit messy and long. Okay, so there is a way to find the inverse of a matrix that's more than a 2 by 2. Okay, and this we will do the next class. Okay, so for now, just the inverse of a 2 by 2. I hope it's clear. Next class, I will show you how to find the inverse of a bigger size matrix.